Hello everybody, so we are dealing with this problem from JEE Advanced 2022 and this is based on the concept of rotational mechanics. Technically we are dealing with the problem of rolling. So let's get started with the problem. The problem is stating a solid sphere of mass 1 kg and radius 1 meter rolls without slipping on a fixed inclined plane with an angle of inclination 30 degree from the horizontal. Two forces of magnitude 1 Newton each, parallel to the incline, act on the sphere, both at a distance 0.5 meter from the center of the sphere as shown in the figure. We need to determine the acceleration of the sphere down the plane in meter per second square. So in case you want to give this problem a try for yourself, you can pause the video and then give it a try, or otherwise let's continue with the problem to get the solution. So we start by drawing a diagrammatic situation of the problem again. So this is how we can redraw the diagram along with all the forces. Let me take you through the diagram. So the problem over here is stating that the mass is equal to 1 kg. So this is the weight mg in the downward direction. The component mg sin theta and mg cos theta are in this direction. Now two forces, external forces of 1 Newton each, are acting at these 2 points and the distance small r is given to us as 0.5 meter. So we can say that technically small r can be written as capital R by 2. So small r can be written as capital R by 2, or we can say capital R is twice small r. So over here the first thing is that we need to find out the instantaneous axis of rotation, and we say that this entire system is rotating about this point of contact, which will serve as the instantaneous axis of rotation. Now because this angle is theta, so the weight mg is also making an angle theta with this line of normal along which mg cos theta is acting. So now since mg cos theta is directed along instantaneous axis of rotation, we say that mg cos theta is not going to produce any moment of force or torque, but mg sin theta will produce a moment of force or torque. So now if we find out the torque about instantaneous axis of rotation, so we can say that about this point this force F is producing a moment of force or torque in this direction. R cross F is going to be directed along this line. Mg cos theta component is not producing any torque, but mg sin theta component is producing a torque in this direction, which is same as the direction which is produced by this force of 1 Newton. Now this force which is at a distance 3r, because small r, so we say that this is producing a torque in the opposite direction, which is in this direction. So over here if we write torque equation about instantaneous axis of rotation, so we can say about these 2 points, we can say that the direction inward is negative. So we say that the direction inward is negative, that is minus r times F. Then again we write minus 2r times of mg sin theta. And then we write plus 3r times F. So over here if we write the net magnitude of torque, so the net magnitude of torque is going to be 3rf minus rf, so we can write it as 2rf, and then we have minus of twice mgr sin theta. So if we substitute the value that small r is equal to 0.5, so twice of 0.5 or half multiply by 1 minus twice of mass is 1 kg multiply by 10 multiply by half, and then sin theta is also half. So over here on solving we obtain the magnitude of torque. If we check, so magnitude of torque is turning out to be minus 5 plus 1 or 4 Newton meter. The magnitude is turning out to be 4 Newton meter, or we can say minus 4 Newton meter directed in the inward direction. So this is the magnitude of torque which we have. Now about this instantaneous axis of rotation, we need to find out moment of inertia. So moment of inertia of the solid sphere about its center is equal to 2 by 5 mr square. Now since we are calculating about the instantaneous axis of rotation, so torque about a moment of inertia about instantaneous axis of rotation is equal to ICM plus md square. So this will become 7 by 5 mr square. So if we use this value of torque or a moment of inertia, then we can say that 7 by 5 times of mr square, mass being 1, radius being 1 squared into alpha is equal to 4, and hence over here if we calculate the value of alpha, then it is equal to 20 by 7 radian per second square. Now the problem is asking us to calculate the value of acceleration. So the value of acceleration can be calculated as acceleration of center of mass is equal to r alpha. So capital R times of alpha, capital R being equal to 1, 20 by 7, and on solving this we obtain the value as 2.86 meter per second square, and this is going to be the final answer for this particular problem, that the acceleration of this solid sphere down the incline is 2.86 meter per second square, and this is the problem from JEE Advanced 2022. For more such content, continue to watch the channel. Please like, share and subscribe.